Hello, you are listening to Pankaj Rai, and in this video we will be discussing the fourth part of Iupac nomenclature of organic compound, which will be dealing with alcohols and haloalkanes. So let us begin with alcohols first. To explain alcohol, first have to explain you what is an alkyl group. So let us begin from there. We are discussing what is an alkyl group. Alkyl is basically nothing but an alkane with one hydrogen less. So you should remember that the general formula of alkyl is CnH2n plus 1, which is one hydrogen less than the alkane. Let me take an alkane and let me begin it from the start. As we know that carbon is having 4 electrons in its outermost shell. Now there comes 4 hydrogens, which makes 4 covalent bonds by sharing electrons, and the compound which we are getting here is methane. Now this methane is an alkane. I said alkyl is a compound which is one hydrogen less than the corresponding alkane. So let me remove one hydrogen from here. Let's say we are removing this hydrogen from the alkane. So now this is called as an alkyl group. To write it, it will be written as a carbon bonded with 3 hydrogens, and it can form one more bond with any of the atom or molecule. So this is called as alkyl, and in this case it is methyl, which will be written as CH3 dash. So that is the alkyl. Now let us move ahead and let me explain you what is an hydroxy group. It is called as hydroxy or hydroxyl or alcoholic group. It is the OH group, dash OH. Now how is it formed? Let me explain you from the scratch. Let me take an oxygen atom. As you might be knowing, the atomic number of oxygen is 8 and its configuration is 2, 6. That is, it is having 6 electrons in its outermost shell. So these are the 6 electrons in the outermost shell of the oxygen. To complete its octet, it needs 2 more electrons. Let's say there comes an hydrogen which is bonding with this oxygen. So now it is having 7 electrons. Let's say there comes one more hydrogen which is bonding with this oxygen again. So now both the hydrogens are having their duplet state and the oxygen now is having the octet state. So it is a stable compound and we all know it is H2O, the water. But what we are discussing is not the water but the hydroxy or hydroxyl or the alcoholic group. It is oxygen with one hydrogen. So let me remove one of the hydrogen. So this is the hydroxy group. Now it is written as an oxygen bonded with a hydrogen and it can form one more bond. It is called as hydroxy group. Now you compare the two molecules on the left and the right. This is a methyl group which can form one more bond. This is a alcoholic group or hydroxy group which can also form one more bond. Let's say this carbon, which is having 7 electrons as of now, needs one more sharing of an electron. Similarly, this oxygen is having 7 electrons and needs one more electron to complete its octet. Let's say that they share these 2 electrons among them. So what will happen now? The bond will complete something like this. It won't be such a longer bond. It would be written in a simple way. I'll show you that. But as of now, as you can see, the carbon is complete with its octet, having 4 electrons of its own and 3 from the hydrogens and 1 from the oxygen. Oxygen is also has completed its octet, having 6 electrons of its own, 1 from the hydrogen and 1 from the carbon. Now this molecule which you can see here is called as methyl alcohol. That is the common name. IUPAC name would be dealt with later on. As of now, this is called as methyl alcohol. It is CH3OH, the methyl alcohol. Let me write the structure properly. It would be C having 4 electrons. 3 electrons are shared with hydrogen atoms, and there is an oxygen having 6 electrons in its outermost shell. 1 electron is shared with hydrogen, and 1 electron is shared with carbon. Now this molecule here would be written as carbon forming 3 bonds with hydrogen, 1 bond with oxygen, and oxygen is forming 1 bond with hydrogen. So this is our molecule, which is CH3-O-H. It is also written as CH3-OH, which is simply methyl alcohol. But how do we write the IUPAC name of alcohols? It is very simple. The alcohols are obtained from a corresponding alkane. So alkane gets changed to alkanol. So in this case we are having methane here, which has been converted to alkyl group, and then it has been converted to the alcoholic group, combined with the alcoholic group, so it is now alcohol. So the methane now would be called as methanol, and that is as simple as the naming or the IUPAC nomenclature of alcohols. Let us move ahead by looking at the next alcohol, which would be ethanol. Okay, now let me remind you first of all what is an alkanol. Alkanol is a compound which is obtained by removing one hydrogen from an alkane and replacing it with OH group. Okay, so let us move ahead with the next alkane, which is ethane. So ethane is a 2 carbon compound, and both the carbons are bonded with the hydrogens. So let me make an ethane for you. Now to convert the ethane to ethanol, we have to remove one hydrogen and replace it with OH group. Now there are two possibilities. We can either remove the hydrogen of this carbon, or we can remove the hydrogen of this carbon. Okay, mind you that there are not 6 possibilities, that there are 6 hydrogens to be replaced. It doesn't make any sense if we are replacing this hydrogen or this hydrogen or this hydrogen. What simply makes sense is that we are replacing hydrogen of this carbon. Okay, so there are 2 possibilities. We can either remove this hydrogen, let's say, that is of this carbon, or we can remove hydrogen of this carbon. So there will be 2 possibilities. So let me make one more here. Okay, let's say there is one more ethane. Alright, so we are having 2 ethane and we are looking at 2 possibilities. Okay, let us remove this hydrogen and replace it with OH group. So now it is a compound which is CH3CHOH. Okay, now what happens when we remove this hydrogen from the other carbon? So this is OH, it will be written as OH CH2 CH3. Now how do we name them? Okay, now remember the rule of numbering the carbon atoms, which states that the numbering should begin from the carbon atom which is closer to the functional group, in this case the hydroxy group. So this carbon is closer to the functional group, so it would be named as 1 and this would be named as 2. Similarly, in this case, the carbon, this one, which is closer to the alcoholic group, will be named as the first carbon and this would be named as the second carbon. Now how does the naming goes on? It is simple. It is alkane dash number of the carbon atom on which the alcoholic group is there dash all. So in this case it is ethane dash 1, because 1 is the number of the carbon atom to which the hydroxyl group is attached, dash OL. So it is ethane dash 1 dash all. In this case as well, as you can see that the OH group is attached to the first carbon only, and it is a 2 carbon compound which is ethane. So ethane has been converted to ethanol, so it will be named as ethane dash 1 dash all. Now as you can see, both the molecules are exactly same. They are just written left to right and right to left. So it doesn't make any sense if we are calling it ethane 1 all, or simply we could call it as ethanol. Alright, so that was the explanation of ethanol. Now we will move ahead and look at the possibilities of propane getting converted to propanol. Okay, so let me make propane first. So propane is a 3 carbon compound. Now let me complete the hydrogen atoms of the propane. So now we are having propane. Now there are 3 possibilities. Either I can replace hydrogen of this carbon atom with OH, or I can replace the hydrogen of this carbon atom with OH, or I can replace the hydrogens of this carbon atom with OH. So there are 3 possibilities. So let me make 3 propanes. Okay, so this is another propane. Let me complete its structure. So here we are having propane. Let me make one more propane. Okay, so we are having 3 propanes here. Okay, now let us remove the hydrogens. In the first case, let us remove hydrogen of the leftmost carbon atom. In second case, let us remove the hydrogen of the middle carbon atom. And in the third case, let us remove the hydrogen of the rightmost carbon atom. And let us replace them with the OH group. Okay, so this is OH, OH and OH. Okay, now in this case the compound would be written as, it will be written as OH dash CH2 dash CH2 dash CH3. This would be written as CH3 dash CHOH, or it is also written as something like CH3CH and OH this way dash CH3. This is another way of writing it, and this will be written as CH3 CH2 CH2 and OH. Okay, let us focus with the numbering of the carbon atoms. As I told you, the numbering would begin from the carbon atom which is closest to the alcoholic group or the functional group. In this case, this is the OH group and this carbon is closest, so it would be named as 1, 2 and 3. Now, as you can remember, this is propane and propane is getting converted to propanol, but the hydroxy group is present at the first carbon, so it would be named as propane dash 1 dash all. So it is propane 1 all. Now look at this one. In this case, this carbon atom is closest, or the OH is attached to this carbon atom. Okay, so we have to begin numbering from left to right or right to left so that this gets the least number. In either way, let's say I start numbering from here, so it is 1, 2, 3, or in this case if I start numbering from the right hand side, so this is 1, 2, 3. In either of the cases, you can see that the carbon atom which is attached to the alcoholic group is getting the same number, which is 2, because it is in the middle. So it does not matter in which way we give numbering. We can say that in this propanol, the alcoholic group is attached to the second carbon, so it would be named as propane 2 all. And look at this one, you can guess it that this carbon atom is closest, so it would be named as 1, 2, 3, and this will be called as propane 1 all. As you can see, the first and the third compound, they are exactly same, left to right, right to left, but this is different, which is propane 2 all. So in this way you can do naming of any of the alcohol. Okay, let me take one more example, the last one for you. Let's say we are having CH3, then let's say we are having CH2, then CH, and there is a OH group attached to this. Okay, and there is one more which is CH3. Alright, now as you can see, this is what? This is butane. Now butane has been converted to butanol. Now about numbering. Now there are two ways of numbering, either left to right 1, 2, 3, 4, or right to left 1, 2, 3, 4. Now look at the numbering from left to right. The carbon which is attached to the hydroxy group is getting the number 3. Whereas if we are numbering from right hand side, the carbon which is attached to the OH group is getting the number 2. So this numbering is correct, whereas this numbering is wrong. We have to give numbering in such a way that the functional group get the least number. Okay, so this is the correct numbering from right to left, and this compound will be called as butane-2-all. So I hope you're clear with the IUPAC nomenclature of alcohols. Now let us move ahead by looking at the haloalkanes. Okay, now first of all, what are haloalkanes? We are discussing haloalkanes. Haloalkanes are halogen derivatives of alkane. That is, I can say that one hydrogen is removed from the alkane and a halogen is replaced, takes place the place of the hydrogen atom, or I can simply say a alkyl plus a halogen will give you haloalkane. Okay, now what are the halogens which we are having? The halogens starts from fluorine, then we have chlorine, then we have bromine, then we have iodine, and so on. Now the fluorine is F, chlorine is Cl, and bromine is Br, and iodine is I. Now let me take an example. Let me take a alkyl. Let us take methyl. Okay, so let me take a methyl here. Okay, so it can form one more bond. Let's say there comes fluorine. Okay, now fluorine, if you remember, all the halogens, just in that case, they are having 7 electrons in their outermost shell, so they need to form only one more bond. Okay, so let's say that this fluorine is having 7 electrons, need to form one bond. This carbon is also having 7 electron in alkyl group and need to make one bond. Let's say they are bonding together, so it would be CH3 and F. So this molecule here which we are having, it is CH3F. So this is the haloalkane and it will be called as fluoro, which is halo, alkane, it is methane, so it will be called as fluoromethane. These four are called as, this is called as fluoromethane, sorry, depending on the alkane the name will change, so it will be called as fluoroalkane. This will be called as chloroalkane. This will be called as bromoalkane, and this will be called as iodoalkane. Okay, now the naming of haloalkanes and alcohols are exactly same. That's why I'm taking the two topics together. Okay, as you can see, a methyl plus halogen is giving you haloalkane, and if you could remember, a methyl plus alcoholic group was giving you alcohol. So in exact same way the naming would be done. Let me take just one example and you will understand it. Let's say we are having CH3, CH2, CH, and let's say we are having Cl here, and here we are having CH3. So this is a butane, okay, where one of the hydrogen of this carbon is replaced by chlorine. Okay, so this is haloalkane. In this case it is chlorobutane. But what about the numbering? Okay, if you could remember from the last part of this video, the numbering would begin from right to left, because from right to left the chlorine get the carbon atom which is attached to the chlorine gets the least number, which is 2. So this will be named as, the chlorine is attached to the second carbon, so this will be named as 2-chlorobutane. Okay, now to distinguish, let me tell you that alcohols are named as alkane, dash number to which the carbon atom is attached dash all, and haloalkanes are named as number dash dash the halogen which is attached and alkane. Okay, so you can try out for yourself the IUPAC nomenclature of haloalkanes. It is exactly similar to alkanols or the alcohols. Thank you very much.